have that display. Oh, it's webcam. That's what we want. Move to top. Order. Move to top. There we go. Look at that. Guess I can stick my face here. Hey everyone. See if this is working okay. Haha. All right. Hey everybody. Getting going here on this live YouTube chat, and got Aaron Eberhard here with me, and also Jake Labrie. Yeah. So we're broadcasting live here, and we're going to do a little overview of some digital tools. And the first one I want to talk about is
Ron's asking you to turn up the mic.
oh, turn up the mic. Let's do that. Hello, testing 1 2 3. Is that any better? Hello. See what we got.
Yep. Sounds like it's coming in better.
Okay, cool. All right, welcome everybody. This is Colin Gilchrist, and joined here again by Aaron Eberhard, Jake Labrie, and we're looking at some digital tools, both for NC programmers and kind of programmers of all types. And there was recently a release by Elon Musk from his company xAI for a tool called Grok. And the word Grok, Grok, comes from a science fiction novel kind of early in the 20th century, 19th century, 20th century, I think 20th century. Kind of like the 1930s, 1940s, and the word Grok means to understand something on a deep level, to fully understand it. So it's not just some kind of weird name that they made up. It's actually a reference back to this book that I'm guessing, that particular word, that particular theme in the book made an impression on Elon. So anyway, Grok 3 is out. It is, you're looking at the interface right now. They now have a standalone app for it. I know they do on Apple at least. I'm Android, so I'm shut out. But I just access the Grok through X, and I am an X Premium Plus user. That level I think is $40 a month, and that gives you access to the Grok 3, but you have basically unlimited input and outputs. Whereas if you're just using the free version, or you're using kind of the X Premium, but not the Premium Plus, which I think is around $20 a month, you also have a slightly limited use of the tool. You get more than the free one, and free, it's the same tool, it's just the number of queries that you're allowed to do. So how many inputs and outputs are you kind of generating? So the window itself has this input window here, and that's called the context window. And so context is really, the deeper meaning and understanding when you're asking a question. It's not just the question, it's what are you actually trying to do? What do you want the outcome to be? What are the things that you want the tool to consider? And it's got a really deep reasoning capability. The other thing is it's unlike some of the other large language models, they are continually updating it pretty much on a daily basis. So as you run it, it has access to kind of current events in the world already built into it. that's current, kind of up to today. And it can also scrape the web. So it can go out to different websites and go look at and get data for you in what they call the deep search mode. And so there's these two buttons down here, deep search and think. Think is great for mathematical problems, hard problems, coding problems, and the regular mode is great for pretty much everything. It's just if you're doing research on the web, you want to use deep search. So that's kind of the difference, and we can kind of explore all those modes. So these large language models, these AIs, are built to take input, break down the understanding and context, and in the case of a generative AI, it is looking to do some prediction and to build response kind of one word at a time. Those models were okay, but the accuracy really suffered. So you would ask a question, sometimes you would get decent output, but there would be some errors, some stuff you have to modify. Other times you would just get garbage, something that's like totally unrelated. With Grok, the reasoning and the understanding is really, really good. It has some really cool capabilities for breaking down information. So we should look at, some questions that you'd like to ask and answer, and I can kind of help guide, well, how do you really formulate a question? And one of the things I want to kind of stress and demonstrate, it's pretty rare for you to ask a single question and get a perfectly formed response. It's much more common for you to start a conversation and within, say, 3 to 10 prompts converge on the answer that you're looking for. So you get something, it's not quite right, you ask it to reconsider, you ask it to consider additional sources, or you point out where it was an error, right? You say, hey, your interpretation there wasn't correct at all. I was looking more in this context. And the other thing you can do is you can ask it, consider my entire last prompt and ask me questions back so that you can better understand what I'm asking you before you begin. So one of the things that I did recently was, and one more feature, by the way. You can actually use this little attach button to upload files. These can be, in the case of code files, you have to name them as .text, or it can be a PDF, for example, and you can say perform an analysis on this document. So I'll just do some queries that I've done recently to kind of give you guys an idea, right? I'm going to go and click on attach. And let me go look in, I've got a directory of documents from the DoD, from the National Institute of Standards and Technology. This is a lot of my life now. This is where I play, is kind of interpreting a lot of this stuff in the DoD side. I'm going to take this document here, NIST SP 800-171R2, which is CMMC. It's actually not the current version, but that's okay. So I'll say open. I'm going to feed it this document, and I'll say, give me a high level summary of this document. And you do the input. And for anybody, oh, this one's not happy. Let's see if turning on deep search. There we go. So I turned on deep search, and sometimes you just won't get a response. Some of that can just be the web interface. So if it's not giving you something, you can click on the little edit button, this little like pen or pencil right next to it, and regenerate the actual output. And so I fed it this document. That document is so 1.25 megabytes, and in terms of size, about 100 pages. And there's some complex data in here. So there's tables in here. You can ask it to perform all kinds of analysis on documents. You can ask it to review your writing and make it better. You can give it a bunch of text and ask it to clarify it for you. So here you can see key points, purpose and scope. It's designed to assist federal agencies in establishing security requirements for non-federal organizations, which are contractors, state governments, universities, that handle confidential, unclassified information outside federal systems. And if I go down and start reading through it, question is, do we miss anything? Is the output good? Or is the output, does it need work? Well, you can kind of feed the conversation back into itself in a way. So in other words, this context window, and this window here that we're talking with is the context window. That window you can tell it to go look on the web. You can also tell it to analyze what it just did. So go back over and review your output. And when you do that, you can also tell it how you want to act. So act as an expert reviewer, act as a cybersecurity expert, act as a shop owner who knows nothing about cybersecurity, and give me, dumb it down, add more detail. The point is, this is an iterative approach. So you start out, you ask a question or give it an action, a task, and then you can refine by asking more questions or adding additional context in the prompt. And you'll also get these little prompts down here at the bottom of your output. So let me scroll back up just to kind of, I'm talking like everybody has done this before, right? And you all know what it is. Let me just go over the interface just a little bit.
While you're scrolling up, Colin, Ron is asking whether it can do any analysis on solid models.
So I don't think it can. When we're talking about looking at the... Yeah. So Ron's question, I would like to analyze solid models of holders and check if the taper is towards the Z positive before using in a CAM-CAV, one application I have asked for years. So to anyone wondering, anyone can download the document he's using, not restrict. Oh yeah, 100%. Yeah, this is a publicly accessible document that's available on the web. And you'll notice that it actually stuck the link to the document down at the bottom of my output as well. So it can operate on text incredibly well. And it also does math brilliantly. So let's look at the interface, and then we'll do some other fun stuff before we get back to some real practical uses. To answer your question fully, Ron, it's not going to be able, its input and output is mainly text. And so the stuff that you want to feed it in is mostly textual, but its understanding of coding is almost unparalleled. So what I would say is, give me a Python script that can import a CAD model in X format, whatever format you want, but it has to be a common format, right? Use common libraries so that you can access this data. And that way it'll go scrape its corpus of knowledge. It'll scrape the web to look for stuff. The coding stuff, like I literally sat down, and I will show you the code on here, and I wrote a server-side game application in Python, and I just kept prompting it, give me this, give me that, review your work, act as an expert coder who works for xAI, and review and the things that it would tell me to do. The insight that it had is just, it's incredible. And so I would then just literally say, it gave me 5 recommendations. I'd say, great, do those things. Do thing 1, here's what I want. Do thing 2, and thing 2, thing 1 being the actual recommendation you gave me. So I would literally respond to its questions and prompts back to me and feed it more context to kind of drive down and get the output I wanted. So we can look at that stuff too. So the interface, if I look at the upper left-hand corner, focus mode, oh, cool. That actually allows you to just turn on just Grok. I'm actually going to use that more now. Hide all the other crap on X. That's kind of cool. Copy share link. So this is a new function and a new feature, just came out recently. And guys, I got to be honest with you. I've been using this like 10 days. So I am an explorer along the journey with you. I'm just a guy who walked up ahead a little bit, looked over the hill, saw the valley on the other side, and then I'm running back to you and saying, guys, there's this really beautiful valley up ahead. So I'm not going to claim to be an expert on the geography that's on the other side of the hill, right? This is a journey I'm going on, and I want to share that with people because I think it's an incredible tool. For the amount of productivity and learning and knowledge that I've had in the last 10 days, it feels like 10 years. It's really weird, but it's once you start using a large language model that has this level of intelligence, you don't want to go back. It's like addicting because it's just, I don't Google stuff anymore, to be honest. I Grok it. It's way better. It's way more capable because it's like a Google that'll actually think. It doesn't just serve you up web links and ads, especially the damn ads, right? It's like, I feel sorry for anyone today in this day and age who's not grokking it. So I don't want to oversell it, but let's continue, right? So there are, depending on the large language model tool you're using, if you look at OpenAI, I've used OpenAI, which is the chat GPT, and they'll have different models. In other words, different sets of trained data that has a specific focus or application. Some large language models are really good at text generation. Some are really good at video. Some are really good at creating programming. Some they have all kinds of different applications, which is the cool part. So let's just make sure. Okay, good. All right. Bookmarking. So as you are creating these different chats back and forth with Grok, you can actually bookmark the chat so they'll stay up at the top. Chat history. I use this all the time, and then start a new chat. So one of the things you'll want to be aware of, when you start a chat and you're going down and you're adding to that chat, you have all of the weight of the output that's happened previously in the chat, and that is going to influence whatever you're typing down here as far as inputs and outputs. So if you want to start a new conversation, you need to go up and click new chat. Otherwise, you're essentially continuing the existing conversation. So those buttons, bookmark, chat history and new chat up in the upper right hand corner. Down in the lower part of the context window here, that's the actual send button. On my phone, I can actually type in chunks of text and hit enter, and it'll actually do a carriage return line feed, and it won't automatically send. For some reason on my Chrome browser, when I type something in, I'm not able to break that text. Sometimes I like to break the text up into logical chunks or paragraphs just because it helps me. Because I'm going through and creating an input, and I'm going and reviewing the input to make sure it makes logical sense before I hit the go button, right? The, send this data into the chat. So because I want you to operate on it. If I go back up and I pull up my chat history, and so these are chats that I've had with Grok. And let me see if I can find So here's a good one. This was my prompt. It was one sentence. School me on Docker development and deployment. And so let's review some of this output, and you tell me if you think it's wrong. Let's dive into Docker development and deployment. I'll break it down into bite-sized chunks so you can grasp the essentials, then we'll switch it all together. Think of this as your crash course. Practical, no fluff. What's Docker anyway? Docker is a tool that lets you package an application with all its dependencies, code, libraries, configs, runtime, into a single portable unit called a container. Unlike a virtual machine, which needs a full guest operating system, containers share the host operating system kernel, making them lightweight and fast. It's like shipping cargo. Standardize the container and it runs the same way everywhere. Development with Docker. So it takes me through the Docker basics, right? Showing the different commands, some examples of how to use them, or sample text. Here's an example for a simple Python app. From this Python library, gives you the work directory, copy this app, run pip install, blah, blah, blah. So it's giving me actual code. It's not going to execute that code for me. And so this is tying back, Ron, with the question that you asked about, I would like it to analyze the solid models. What you want to do is have it help you write a tool. And that tool can be Python. That's probably the easiest one to get started with, or any other scripting language of your choice. You want to develop an app. You want to develop a lightweight standalone app that you can launch that app. You can feed it a file, or you can feed it a folder with a group of files inside there and have it iterate through the collection, check each one, and report on it. Now, as far as manipulating the 3D CAD model automatically, I don't know if we're there yet. There's one way to find out, though. It's to start interrogating Grok and saying, here's what I want to build. Here's the context of what I think I want that thing to do. Let's get started. Now, it does assume that you've got the ability to understand the output. The cool thing is you can start with any of these outputs and say, hey, I'm lost, man. Give me the Docker, break down the Docker file basics completely. Let's start there. And so you can really dive into, here's what I asked it, here's what it output for me. Yeah, exactly, Ron. And that's why I say it's kind of always an iterative approach. Like, get started. I want to create a tool. So this is and I'll just scroll through this real quick, right? Here's some Docker Compose stuff, development workflow tips. the actual steps to do the deployment, and this is all the code stuff that you would run. And I know it probably just looks like Greek, right? I don't speak this stuff, but I've got kind of the super smart professor that is Grok that I can take any of this and say, man, you posted something like CI/CD integration. I have no idea what that means. Give me a full breakdown. So I'll just kind of go through this real quick, right? The other thing that I asked it to do, so oh, here we go. So I go down, it gives me all this output, literally one sentence of input, and I get all this output. And then I get down to the bottom here, and it says, okay, that's Docker in a nutshell. By the way, when you have the input and output, this is what we call an input context window. The limit for the input context window is roughly 128,000 tokens. A token is not necessarily a character. It's more, you can think of it more like a word, but it can operate on a PDF file of, say, up to 5 megabytes. But you can also tell it to do tasks in chunks. So you can say, hey, Grok, I've got this really large PDF file. It's 15 megabytes. I'm going to break it up into 5 3-megabyte chunks, and I'm going to upload each chunk. And in your memory, I want you to combine all the chunks together so that you can consider all the data. You can do deep cross-referencing. You can do deep search. It's really pretty incredible. You guys ever want to do something with an Excel spreadsheet, an Excel file? You can have it build you formulas to do all kinds of stuff. You say, hey, I've got this text input. I need to build something that does this. I've had it do some really cool stuff with Excel. So when it gives you this output context window is limited to 32,000 tokens. So it's 128 in, it's about 32,000 out. In practice, that is roughly 4,000 to 6,000 words. It's a significant amount, but it's not unlimited. And that means if you are anticipating output that's long, just ask Grok to break it into sections. I literally did. I don't want to keep this one open, so I did a full deep dive into CMMC, and I had it create me a entire roadmap that actually consisted at the end of 421 chunks of data. So all of this output was from it reviewing multiple related and linked files from NIST. And so all of this output was generated for me by just a few prompts. And I was able to kind of take that and save it. So I'm building a presentation. Return on investment for controlled unclassified information. ROI for CUI. How CMMC compliance pays off for your machine shop. And I wanted an entire roadmap as a giveaway, something I could give to people. And I wrote pretty much the whole thing except for a little tweak here and there just with using Grok. I mean, this ended up being a 700-page document. I did this like in an afternoon. So that's kind of the power of what it can do for you. you'll notice that I did this whole output getting back to this Docker thing, right? Tell me about Docker. So it tells me all about Docker. At the bottom, when you get an output, you do get some controls on that output. You can like it or dislike it. This helps give feedback to the algorithm to know whether it generated a good response or not. You can copy that text. So there's that copy button to grab a chunk of the data. You can regenerate. So this is where sometimes the output will get interrupted. And if it gets interrupted without it being an output issue, in other words, you're not trying to output 7,000 words, you're only getting 6 because that's the limit. You start running and it's giving you, the first 12 sentences and then it just stops in the middle of a line. Sometimes you need to actually just regenerate it. It's not perfect every time. So that's that regenerate button. And then there's a share button. So you can generate a block of text output and then you can share that chunk, or you can share the entire thread, right? The entire conversation or chat. So Ron asked a question. He says, I want to build a Python, and I could just tell it, I don't even know what language. Tell me the best language to build this app in, and it would give you a recommendation for that. So I want to build a Python app which can import, let's call it Parasolid. A Parasolid 3D model of a tool holder for a milling machine. So you notice that I'm not just saying I want it to import a model of a tool holder. I am trying to be a little bit specific and provide more context about the actual task that I want it to do, right? So I want to build a Python app which can import. I need it to detect the orientation of the large taper feature and report which major Cartesian axis the taper is centered on. I'm expecting this will, always be X, Y, or Z. I need the short end. I need the small tapered end of this. I'm going to get fancy. A frustum is a cone that is also truncated at the tip. So I'm using a mathematical term on purpose. And, if you don't know the vocabulary, it's okay. You can give it some input and get started and then continually refine and narrow it down. So I need the small tapered end of this frustum oriented to point away from the origin, always towards the Z plus direction. I want to be able to ingest a folder full of files and have the program iterate through the collection of files. So iterate through the collection of files and report any which are not oriented correctly. I want you to write all the code for me, or for my program. And then I'm going to say something like this. Before you start, ask me any questions, or if you need additional context. So I'm trying to be descriptive, but I'm also trying to kind of tell it what I want without telling it how to do it, if that makes sense. So, all right, we can try it without deep search. We can try it with deep search. I'm going to try it with deep search off. I'm just going to try the regular Grok first. So it's doing some thinking. And what I asked it was, the key here was this last sentence. Before you start, ask me any questions or if you need any additional context. So here we go. But this also kind of shows you the intelligence that's already built in. File format. You mentioned importing Parasolid 3D models. Parasolid files typically come in X_T text or X_B binary formats. You notice it actually found and knew those formats. Do you have a preference for which format your app should support, or should it handle both? If both, are there any specific versions that you're working with? So I'm going to say, here are my answers, with a colon, and then I'm just going to do one, and you could probably just do one dash. I do one period, you know, with a closed parenthesis, just to kind of help give it some nice dividing. And I'll just say handle both up to the current release, but give options to handle all lower versions as well. So that's the first question. 2, taper feature definition. You want to detect the orientation of the large taper feature, a frustum, in the tool holder. Can you confirm what defines this feature geometrically? For example, is it a conical frustum, a truncated cone? Are there specific attributes, diameter differences, length, or annotations that reliably identify this taper in the model? Should I assume that large taper is the most prominent conical feature in the model? So you can already see, in trying to understand my input, it's already got quite a bit of the understanding already. It's just asking for some clarification. So I'll say yes, a truncated cone. Generally the largest feature by volume in the model, and which is most prominent. So I think that's a good answer, good enough for number 2. Orientation detection. You want the taper small end to point to the Z+ direction and the taper to be centered on X, Y, or Z. To clarify, does centered on means the taper's axis of symmetry. The line from the small end to the large end is aligned with one of the Cartesian axes. Should I assume the tool holder's default orientation in the parasolid file might be arbitrary and the app needs to detect and correct it? So I will say yes, centered on the axis of symmetry, and I'll just put in parentheses rotation. Always aligned to one of the X, Y, or Z axes, but orientation can be flipped or set on one of these axes at random. However, the holder will generally not be randomly rotated to where the cone is not on a major axis. Okay, so that's number 3. 4, coordinate system. Parasolid uses meters as its default unit, and its coordinate system is typically right-hand Cartesian. Should I assume the origin 0, 0, 0 is at the base of the tool holder or elsewhere? If not specified in the file, how should I determine the origin relative to the taper? And I will say for origin 0, 0, 0 will always be specified, but the holder may be translated along one of the Cartesian axes. Let's see, part of the model may be touching or intersecting the origin, or the entire model may be translated and not near the origin. I don't care about position, just the taper orientation, right? So I'm really being specific about there's all these potential cases that you may run into when we are programmatically interrogating the data. And the goal with this is to set up kind of an applet, a Python app that's going to run that will be able to take this model, bring it in to memory without a graphic user interface. We could add that later. We just haven't said anything about it yet. So one thing at a time. And that's kind of the cool thing here, right? Is you can code. You just let Grok do the coding and you tell it what you want and you iterate through a series of prompts to get what you're after. And I'm going to say for the detection. Okay, so that's number 4. So 5, what do you want? A simple list of file names that are incorrectly oriented, a detailed output, should the app automatically reorient and save corrected files or just report the issue? Well, shit. I mean, don't tempt me like that. So I'm going to say both a simple list and the app should reorient and save the corrected file with the original file name and let's see, appended at the end. And we'll say the string, and the string underscore mod appended at the end. Okay, cool. So that's number 5. 6. You mentioned a list ingesting a folder of files. Should the app recursively search subfolders or only process the files in the specified top level? Well, I mean, who doesn't want to recursively search the subfolders? Am I right? So, and by the way, that's a little humor there, guys. Yes. Recursively search subfolders, and let's be polite. Why not? Please. How about that? And then libraries, capable Open Cascade, Python with Parasolid import add-ons, CAD Exchanger, Siemens, that's not freely available. Okay, so here we got a problem. To process the Parasolid files, I'll need a library capable of reading the files and analyzing the 3D geometry. So Open Cascade via the Python-OCC with Parasolid import add-ons. This may not be free. Okay, we got to pay a license. Fine, we'll pay a license. We'll figure that out if we have to. CAD Exchanger SDK. Commercial, supports Parasolid natively. Siemens Parasolid SDK. Since this is a coding request, I'll aim for a solution using open source tools where possible or a simplified approach. Do you have access to a specific library? And we'll just say 7. Let's try open source for now. But separately, give me information on Siemens Parasolid SDK. Cool. And assumptions, what's Grok going to assume? Taper is a conical frustum. The app only needs to detect and report orientation, not modify files. Taper small n should point z plus. Files are that. And I'll say 8. Yes, but I added the modify file option. Where was that? Under your question, number 5. Okay, so this was relatively quick to write because it was like, all right, I know what I want to do. Here's what I want to do. You may be asked a whole bunch of questions when you give it a prompt like, before you start, ask me any questions or if you need additional context. But the quality of your output when you give it this extra context is pretty great. So I'm going to say, grok something. This is real time, guys. This isn't like give it a task and you wait, you know, an hour for it to give you something to try. Notes on the code, dependencies. You'll need to install this. Boom, boom, boom. Taper detection and orientation. Boom, boom, boom. Giving me some information on the Siemens SDK. All right, so it looks like I can get a developer license. So I can get a 60-day trial developer license, so we could add that to there. Now, I saw in the output notes. So there's some dependencies. In other words, we have to install a library. It's a function placeholder. Open Cascade doesn't natively identify conical frustrums. You need to analyze the face geometry. Okay, so the library doesn't have a function to natively identify a conical face geometry. So we're going to have it add one. It doesn't support parasolid files directly. Well, if Open Cascade doesn't do parasolid, let's do this. Okay, so we're going to say refactor the entire project to use step file import and output instead of parasolid. Now, can you imagine if you had gone to a developer and you had said, hey man, I want you to write me this app to input to ingest parasolid files and do the output. And then after he had written a bunch of code for you, you went back to him and said, yeah, great, scratch that and do the whole thing in a totally different language. Oh, by the way, yeah, screw Python, write it for me in Java. Give it to me in JavaScript. Give it to me in C#. It's like a sentence away, guys. So refactor the entire project to do step. Now keep in mind, it's retained all of the context in the previous conversation that we've had. Not in additional or separate conversations, but everything in this window. All right, so it's rewriting it. Okay, and at some point, oh, it's still thinking. So right down here, you can see there's a stop button that's lit up. That's a cancel, so we got to wait till it's done generating its output. Oh, so it changed all my shit. Sorry, I love it so much. Sometimes I get a little squirrely. File format, import, export, it's telling you some of the extra functions that can be added, all this stuff. Let's say this is all in one big file. Let's do let's modularize the code and add a configuration file. And so now it's going to break it out with this little project structure. Guys, I don't know how to do any of this stuff. I just know how to talk to Grok. Okay, you asked me to do this project in Python or in whatever, and it's like, man, I got to start by doing a whole bunch of learning and research, right? In the old days, I'd go and I'd get a book. My bookshelf's full of them, right? Learn about this thing, see if I can do it, get, a tenth of the way through it and give up because it's just too much. But here's my module, my source geometry.python. So it's going to import all these modules, and it's got all this code. Here's another module for my file processor. How long did this take? right? Took a lot longer with me talking about it. So, you know, going through and like, I mean, it's full complete code. You know, it's crazy the amount of stuff that I've been able to do over just, you know, the last few days. And then you get down to the end and you'll see stuff like, all right, there are limitations. Detection is approximate. Only step and step files as configured. That's great. It's got a README in it. I see in the chat window, Ron, Colin will do it for 4K. LOL, right? Exactly. Yeah, and so that's why I just kind of wanted to, you know, start out and just introduce, you know, I always find I learn much better by seeing something demonstrated than just reading about it, right? And there's nothing like starting with a blank prompt and you give it some direction and description and you start getting some really sophisticated output. Crazy stuff. So let's do another one. Let's do a new chat. Here's one I did recently. It was kind of fun. So I'm going to do a deep search. And let's say I want to understand FANUC, let's see, 5-axis machining better. Fully explain FANUC tilted work plane G68.2. Now, deep search is going to actually look and scrape the web, and it will actually show you its thinking as it's running. This is not the output. This is the thinking behind the output. So reading through this can be really cool because sometimes as you see how it's thinking while it's thinking, you can see where you're like, oh, okay, well, I didn't provide enough context here because it thinks I meant this, but I really meant something different. And for me, it really helps me to be specific with my vocabulary, right? So it's still thinking. Right up here, I've got it. It's been going for 48 seconds. Show thinking. It's just researching 5-axis machining. It hasn't even gotten to my request. It's like, I want to understand 5-axis machining. I'm going to do research on 5-axis machining. Then it's going to look for the tilted workplane G68.2. And now, you know, it gives me what I asked for, which is essentially a breakdown. Here's some of the key points. What is 5-axis machining and G68.2? How does G68.2 work? Practical considerations. Detailed functionality, talks about Euler angles, roll, pitch, and yaw, 3 points, 2 vectors, projection angle, gives me a sample of the code. Cool. So good breakdown, gives me, it'll do tables. You can ask it for data tables. You can ask it for different types of formatting. It's giving me samples. That's great. Okay, so let's do something fun. Let's say I've got 2 sets of 3 by 3 matrices, which each represent a Cartesian coordinate system in unit vectors. The first is my WCS, And this is my world coordinate system and the main reference plane for the second matrix. I want code to calculate the G68.2 using Euler. So it's just thinking, guys. Exploring G68.2, calculating Euler angles, determining the rotation matrix, refining the angle calculations. Direct answer, blah, blah, blah. Talks about the calculations, gives me the actual mathematical formulas, and give me a Python function to do this. Oh, now here's here's something I want to do. I'm going to stop this. I've got deep search on. Deep search is web scraping, guys. So if I'm switching the context up, I'm going from like, hey, give me all the information you can find on the web about this, to doing an actual task. I'm going to turn off deep search. Then I'm going to go back to edit. And let me do it without. So once deep search has been activated, it's going to keep running. So I've turned it off. I got to let it get through this output. If I stop it, it's not really going to understand that I don't want deep search. So we're just going to let it run. So there it's going. It's doing this deep search. Yep, it's thinking. Okay. Oh, it actually did it. Oh, sweet. Okay. So here we go. Here's my Python function. Calculate my G68.2 Euler given the matrix. And there's all my code to do that. Yeah, here's the detailed code with comments. Boom, 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 boom. All right, now we've got the deep search turned off. Why not do it as JavaScript? Not that I would, not that I care about what it is, but I'm just kind of showing the transformations you can do on data are pretty stunning. By the way, I turned off deep search before I put in that new prompt. So rather than doing the deep search on the web, it's iterating on the code or on the conversation that we've already done. So here's the calculations to do the G68.2 with JavaScript instead. Okay, so what do you want to write? What do you want to do, right? We can go back to the program that does the, manipulates the CAD files, all kinds of stuff. I want to do an actual practical demonstration, like a real world problem, not just some kind of example stuff. So I think that's the one we're going to do next. I'm going to do a new chat. So this came about because I had a problem at a customer who had done a bunch of work over the years on an NX post processor. So this is Siemens NX. And it's for an Akuma Hawa 5VA, 6VA, right? So this is for just a 3-axis Akuma mill. And I wanted to have the exact same style and formatting and all of the same customizations. Because, everybody, when they get a post, they tweak the header output so that it gives you the information you want the way that you want to see it. They adjust comments, do whatever you want, right? Now you've added a new machine to the shop floor, and you need to take that and reformat it, right? So what I'm going to do is attach. Oh, and so here's one of the things I got to do: the custom files input. It'll take GIFs, JPEGs, portable network graphics, PDF files, .text, .txt, and it'll take, can't tell if those are databases or spreadsheets. But anyway, I need to give it a text file. So what I'm going to do is come here and I'm going to copy these 3 files. And let me rename this. So I'm basically going to take the actual file extension and put that in the name of the file so I can keep track of it. And then I'll change the actual extension at the end to txt. So this one is going to be tcl.txt. Perfect. Okay, so I got 3 text files now that are my 3 original files: a TCL file, a PUI file, and a DEF. These are the old school Siemens NX post processors. So I'm going to attach them. And I think you got to do them one at a time. Oh, media failed. Let's try that again. Oh, and I want to make sure that's closed. There we go. Attach. I can maybe do them as a collection and put all 3, but I'm just going to play it safe. So I'm going to say these 3 files are a collection Okay, so these three files are a collection which form an Akuma 3-axis mill post processor for Siemens NX. I need to analyze and convert the text from Okuma mill G codes and M codes into Haas mill G codes and M codes. I want you to analyze the text. Oh, I already got that. Okay. All right, that's enough. Couple of sentences. Okay, so it did an extraction, and it sees that, all right, these are the G codes and M codes. Okay, there's the M codes for the Akuma. Compare with the Haas. Let's see, tool length compensation, use not supported by Haas, use G43 instead. Let's go M codes, conversion table. So here we got a conversion table for the G code conversion. And what am I looking for? How about G54? Let's see. So it found some differences, but it's giving me some snippets of a few things it's changing. And to be honest, guys, having done this over the last weekend and looking at it, and I said, oh, you know what? It's really misinterpreting this. So I need to give it more data. So I'm going to do Hellman CNC Haas mill code list. All right. So here's the G code list for the Haas. And I'm going to copy it. And back here in Grok, I'm going to say, that's not quite right. So I'm giving it feedback, right, that I asked it for something. I was expecting something different. I didn't really get what I was looking for. So here's what I'll say. Build a cross reference table of G codes and M codes using these data sets. Use this table to iterate on the three files and make all necessary changes to convert from Akuma to Haas. Also check file name references and change these file names to Haas VF 6 mil. All right. Here is the list of Haas G code and M code. And then what I'm going to do is I'll do an equal sign in an open bracket. I want to make sure that I've copied the G codes, and now I'm going to paste it in. And I'm just going to do a space, and let's go look at G and M codes. Let's go look at M codes mill, Haas mill M codes. So I'm going to grab the Haas mill M codes. And then I'm going to do a close square bracket. So I've got the open square bracket, the closed square bracket, and I'm going to say, and here is a list of Akuma mill G codes and M codes, and I'll say equal open bracket let's go look at Akuma mill G and M codes. Here I think they actually do it as a list of both, and there's way more. That's great. No problem. So I'm going to copy all of that, go back to the context window, paste that in there, square bracket, enter. Ooh. Yeah, so it said something about I want to look at the image, but I'm a little blind at the moment. I don't know what that was about. So I just regenerated it. And so now it's actually building a reference table. G43 is the same. And it's doing it. I forgot to include some instruction that's important. And that instruction is I need to give it an example of where the G codes vary. So things like G15H1 for work offsets versus G54 series. So it's doing it. We'll see how far it gets. And one of the things I know is that there's too much output for it to actually finish and complete the task. So we'll let it run till the end, and eventually it's just going to truncate. So the thing you have to be aware of, right, is you really need to be able to analyze the output and tell it where it's doing it right and where it's doing it wrong. So it is still super easy to get bad output, right? It's not a thinking machine. It's a reasoning machine that reasons on input and then generates output. And you still have to be able to judge that output and then give it additional instruction so it knows, how to actually do the task the right way if it's not getting it right. So it's almost done. It's going to choke here in a minute because we've generated all this output from a single prompt, and that's where we're going to hit that number of character limit. Still going. There it goes. There it goes. See, rest of the file remains unchanged. No, it doesn't. You just ran out of context window. So, that's not right at all. Go back and review the G code. Here is an example. For work offsets, Akuma uses G15HXX, where XX equals work offset number, like G15H01, G15H03, etc. For tool length offsets, Akuma uses G56 H1, where Haas uses G43 H01 for the exact same function. You need to I love this word for prompts. Comprehensive, full, complete. The other one is exhaustive. I want you to do all of it. I don't want you to skip any of it. So a comprehensive mapping from Akuma codes detected in the 3 files to Haas codes and make the conversions in the new output files you're generating. Okay, so few sentences, but real clear instructions about here's an example where the input file, so for work offsets, Akuma, yeah, I think that's good enough. All right, let's see what we got. Haha, you're absolutely correct, and I apologize for the oversight. It did not adequately address the specific Akuma work offset syntax. And you notice it says Haas G54 through G59, right? And extended offsets, nor did it fully account for the tool length offsets, blah, 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 blah. Okay. There we go. G56 to G43. So we got that mapping correct. So I can tell you what's going to happen. We're going to get the def file and we're going to get the other file, and then it's going to fail on the TCL because the file's too long. So once you get to the end of this output, the next thing that I tell it is, all right, let's take it one file at a time. Give me the def file, give me the PY file. Now take that TCL file and break it into chunks and output the chunks and put a comment at the bottom of each chunk that says, this is the end of the chunk number. And then in the next chunk that you're going to output, put in a text line that says this is the start of the next chunk, and keep a running tally of the number of chunks and which chunk this is, and make sure you report that. And then you tell it some context. Like, hey, my intent here is I'm going to have you output like 10 of these chunks, and I'm going to copy and paste them into a single file, and I want to make it easy to make sure that I didn't accidentally add anything that doesn't need to be there. Go. So I'm providing, a little context back about what I want it to do and what it's doing for me. Okay, so that's the modified def file. Then we got the modified PY, and like I said, it's gonna fail in the middle of this TCL file because the TCL file is the big one. That's okay. We're at the point now where I can at least show you some of the output because it's writing the code for me. The code only exists in this chat window. So I actually have to move this into a physical file. I have to copy and paste it as text into a file that's actually on my system. So that's kind of the next step in this journey. And we're not going to do the full thing. I'm not going to go through the TCL file and run it in NX and do all that stuff. We're exploring the actual Grok tool to do the conversions, right? Okay, so like I said, it's gonna rest unchanged. Yeah, no, you just couldn't do it. That's okay. Right now, we can at least do the next step. So the next step is what they call file diff. So here's let me just make sure this is the actual start. Yep, here's that def file. So here's my plain text, and I should be able to copy that code. And let's go to my folder. It's the def. So I'm actually just going to use the existing one. So I'm going to take this, Control A, and delete it, Control V, the new one, and then I'll save this. And this one is going to be the .def, but it's also going to be a Haas VF6, and what is today? 03/01/2025. Man, how time flies. Okay, so that's the .def file, and let's do the PY as well, because I think that'll be a good example. Okay, so here's the modified PY file. Yeah, I can rename it first. Let's go. Yeah, this is going to be a Haas VF6, and I should have copied the string because I'm lazy. Okay, so now I've got, I need the actual file contents. Let me delete that. Let's just make sure I've got a fresh set of data. I'm going to copy that in there, and I'm going to save it. Okay, so the other thing I kind of wanted to talk about in this little live chat was something that is commonly known as file diffing. Uh, so there's a company called Scooter Software that makes a product called Beyond Compare. It is probably my favorite file difference utility. There's the old version, older version, version 4, etc. It is not a free piece of software, but it's something like $30. I don't know. With inflation, it might be $50, but it was relatively cheap back when I bought it. And I think it's still relatively cheap today. One of the things I really like about it, when you install it, it actually adds this little function to your right-click pop-up menu in Windows so that you can just launch it without having to launch the program, select a file for the left side, then go and browse and select a file for the right side. So what I'll do here is let's do the def file first. I'm going to take the HOS test. I'm going to right click and say select left file for compare. And then I'm going to do the same thing with the Akuma def file. And when I right click, you'll notice I now get compare to test file. Say OK. And a lot of file differences are looking line by line. And part of the problem is they don't do a great job of being able to line up sections that may be mismatched in terms of line position. So Beyond Compare actually is looking at code chunks as chunks, and if something was moved, if we took the address declarations and we moved them or we rearranged some of them, you can actually take a line, right click on it and do align with, and then go scroll in the other section and click on a line that you want to align it with, and it will actually line up those chunks of code. It's pretty sweet. There is a bar on the left hand side which gives you a visual colorized map of the differences. So as I scroll down here, you can see here this cycle step 1 was output as an I value, and Grok changed my code with added a comment, so it made it a Q, and then it says change to Q for HOS G73 G83 PEC increment. Well, that's cool. What else? So here's some address declarations that are from the Akuma that aren't used on the HOS. So you notice those didn't get copied over. Let's see what else we got for a chunk. Circular move turbo. Do we need that? I don't know. I mean, remember, Grok is kind of take the input, generate the output. So if we need this turbo move, I'm going to copy it over, and I may have to do some additional manual work to clean this up. Change from G54 to G18 equivalent. So we'll have to look and make sure that that's correct. Doesn't look like that's correct. But you can see that if you can spot the problems and then go back in and give it specific instructions, it's a pretty powerful tool. So anyway, I just wanted to kind of point that out. That's the def file. I think the PUI is going to be a little bit more instructive. So I can actually select two files and then just right click and do compare. So here you can see it renamed that PUI file to the VF6 successfully. We have to make sure that the names match. changing. Hey, look at this. It actually read that it was a VF6 and it gave me the correct XYZ travel. That was not expected. Pretty cool though, huh? So gave me these codes, replaced with the G54, sys reset. Now it looks like there's a whole bunch of stuff that got dropped off. Why did this get dropped off? That's, was my context window too small? So those are the things you have to kind of know how to do, is like judge the output. It's not always going to be perfect for you. So you have to know, all right, I'm going to give it some instruction. I'm going to get some responses back. I'm going to get some feedback back. Now, what do I do with that? How far do I go? And, you know, this is a language it doesn't know so well the way that it knows Java or Python or some of the other languages that we interact with. Let's see. You guys want to jump on for a sec? Anyone want to talk about anything?
Do you want to go through your NC plot then, and I can jump in afterwards?
Yeah.
Would you like to take a little break, because I can point out my favorite thing? I was going to bring up HSM Advisor.
Yeah, why don't you do that? Why don't you take them through just HSM Advisor real quick? That'd be cool. And then, yeah, because I'm going to take just a quick break. I can only talk straight for so long.
Do you have HSM Advisor on this computer?
I don't know that I do. You can download it.
Okay.
You might as well show them. Show them where the website is and all that stuff. So.
Hey guys, Aaron Eberhard here from Vector Manufacturing. So I'm stepping over here, and one of the things I wanted to talk about was the way that I use a program called HSM Advisor. Now, Colin doesn't have it on here, and I don't want to go through, setting all this up, because I'm sure you guys do not want to watch somebody set up software and log into their account and everything. However, what I wanted to point out was one of the ways that I use this. Now, for anybody who hasn't seen this before, this is something that I recommend. I know Ron's been using it for years as well. In fact, it was one of the first things I bought when I left my cushy corporate Mastercam job and went out into the into the real world and was programming and running machines and everything. So the magic thing about HSM Advisor is it takes into account the material that you're cutting, the physical characteristics of the tool. And I'm just going to zoom in. Again, not running the real software here, so we're just going to use their screenshot for a minute. But what this is doing is taking the type of tool that you're using. In the screenshot here, it's a solid end mill, the material that it's made out of, carbide, and then if there's a coating on it, TiAlN, AlTin, whatever. You could have a ZRN coating. It has the NACRO, NACO, all the common stuff in there. And then you literally define the physical characteristics of this tool. So you're going to say that I have a 1/2-inch end mill that is sticking out of the holder by 1.5 inches, and it has 3/4 of an inch of flute length, and it's got a 37-degree pitch. And if it's a steel cutter, maybe you're using a 4, 5, 6 flute, whatever. And it's taking all of that into account then, and it's going to give you a recommended depth of cut, width of cut for that material. You could turn on whether you're using a high-speed machining mode, which if you're a Mastercam user, that's going to be the Mastercam dynamic toolpath. If you're using something like CamWorks, that would be either the adaptive algorithm, or if you're in a newer one, it'll be the Volumill cycle. Fusion calls it adaptive machining. All of those things are essentially doing more or less the same thing. If you're using something like SolidCam, their iMachining would be handling this. So all of these guys, and that takes that chip thinning into account. Now, that's fun, and that is awesome, because that allows you as a user to be able to jump into any machine at all. Doesn't matter whether you've got an old clapped out, converted Bridgeport in the back, or you're running like a older Haas VF3, or you're running a brandy new, Micron DA300 or Makino DA300, I meant to say, whatever it is. you know, all of those things. You can jump in here and tweak and tune. You could literally define your torque curve and everything for your machine to keep things in the best cut conditions. But what I wanted to talk about today specifically was these gauges at the bottom and how to use them. So these things will give you all of the physical cut characteristics of the cut itself, of whatever it's recommending. And as you change and input the parameters, it'll adjust these numbers at the bottom. So for example, in their little screenshot example here, the cut that they have is going to take 3.97 horsepower. Now, that's relatively easy to find the torque or the horsepower required to make a cut. But the big thing for me is the torque, because this is really showing you how much this is really going to put into the part. It'll also tell you what kind of deflection you're going to be seeing at the cutter itself. So let me use a real world example of how I utilize this in my day-to-day shop. So most of what I do, to be fair, is programming for other people, training other people, stuff like that. But I do in fact have a machine in my garage, and it's an older robo drill. Now, for those who aren't familiar with robo drills, this is a much lighter weight machine. Mine's a 1998, so it's just a single contact BT30 tool holder. So it's not going to be super heavy duty, but mine also has a pallet changer on it, which awesome for flexibility. However, that is reducing the rigidity of this machine, which is already sitting in residential concrete. So I found pragmatically, if I look at the cutting force using HSM Advisor, about 120 pounds of cutting force are really the most that I can do without causing vibration, additional wear. So I can use this to really tune in a cut that is maximizing what my machine could take. So for example, I was doing some some fixtures out of 17.4 stainless just a couple weeks ago. And this allowed me to go through and iterate real fast with, oh, okay, if I put a 1/2-inch end mill in there and I put in the parameters that would keep it happy, that's going to be like 380 pounds of cutting force against it. So that's not a great idea. So then that allowed me to go, well, maybe I should try a 3/8, and maybe instead of doing I think I wanted a 500 thou depth of cut, I backed it off to 300. And then you could adjust the slidey bars here or type in numbers and go, okay, well, give me 70% of the recommended. And the other way that I use that is when I'm designing fixturization. As you guys know, every time you clamp on something, you're putting stress into the part, right? And you guys are machinists. You know that when you remove that material, that stress of the cut itself has to go somewhere. Now, if you're doing a real good job and you're managing that with like a high-speed machining, maybe dynamic toolpaths and Mastercam, a lot of times you can work without putting too much residual stress into the part. But if you're clamping on that thing and you're machining it, what's going to happen as soon as you release those clamps? Out of tolerance, right? So by utilizing this function of the high-speed machining, or the HSM Advisor, the cutting force itself, you could really tune in your work holding. So you give yourself a safety factor, right? But if you've put all of your input in and you're looking at your heaviest roughing and the cut says it's only going to take 150 pounds of cutting force, well, then you could tune in the clamping force. So that way, maybe you have 200, 300 pounds. Most people will go in there and they'll throw something in a Kurt 6-inch vise and never think about how much clamping force they're actually putting onto the part. They're just concerned about when they release it, how's it going to spring? So this allows you to really dial that in. So that was kind of the contribution that I wanted to toss in there. Was I use this. I highly recommend it. I know they've got a phone app. They do have plugins, so you could plug in your Mastercam tool library into it. There's a whole bunch of really great things. And the other thing that I always give a shout out to any single thing. Whoops, I wanted to go to the buy now page here. Any company that's still giving you a lifetime license, they deserve your patronage. I'm not affiliated with these guys at all, but I am a believer, and I've converted all of my customers to using them. That $200 lifetime license will also give you the full version on your phone. So I don't have a good way to show it here on Colin's screencast, but the phone app is basically fully featured, and again, lets you do that on the fly. You could stand there in front of your machine, choose your material, choose your cutters. All of that will work out. So that's my plug for an unrelated, unaffiliated company that I just really believe in. Eldar did a great job with this HSM advisor, and like I said, I know Ron's in the chat and he uses it as well. It just gives you a great baseline. And the other thing is, it's actually a really great reference. All of the tabs along the top, and I wish Colin had it installed for me here, but all of the tabs along the top give you immediate reference to everything you need to know about certain threads, GD&T references. It's got some geometry calculator, but we're all CAM programmers. We probably don't really need that one. Okay. So, yep. But there we go.
Yeah, I'll be right back.
Okay. Cool. Yeah, Ron said 50 of our customers. Yeah, I'm probably I don't know if it's exactly that much, but absolutely catching up with that because a lot of my customers are in that same boat, Ron. Well, it looks like Colin just ran out for a second, so I think he'll be right back. Jake, do you have anything you'd like to add? Anything you use in your day-to-day life? No?
Nothing that everyone doesn't already know about, I don't think.
Okay. So, well, I guess you used the trig calculator this week? All right. Well, Ron, Ron's there to prove me wrong again. Yeah, I mean, the calculators are really handy when you need them. Most of the time I'll, of course, use CAM if I'm working at my desktop, but, using the phone app, it's the best damn geometric calculators I've seen for sure. So, hey, in the comments, what CAM system are all of you guys using? So just, if anyone doesn't know me, I used to work at Mastercam, so I'm obviously a totally unbiased source, but I am actually a Mastercam partner with Vector Manufacturing. I know Ron and I have worked together before. Ron's, of course, a Mastercam user as well known from there. I see a couple of people that I recognize from eMastercam, so I'm assuming you guys are also representing Mastercam. Here, I know Colin with the Philips Corp is they're a Mastercam partner, but also they deal with NX as well, which is why Colin was converting that NX post. So looks like everybody's from the community. All right, well, I'm going to step away. Thanks for letting me chat on the microphone. And Colin will be back in about 5 minutes if you want to go grab a drink of water.
Just stepped away.
Beautiful.
There you go. I've got to bounce.
You gotta go?
Yeah.
Okay.
Yeah, it's 3 o'clock was the time I was looking at as well.
Okay. Cool. Well, we can wrap it up.
Gotta leave fast.
Yeah, right? Oh, that's cool. I like the little graphic thing. All right, what do we got here? So we still got the broadcast going. Customer had a programmer do. Op one was taking 26 hours. Let's put some light on in here. All right. Hey guys, I'm just gonna say goodbye to Jake and Aaron here as they're getting ready to head out. And then I'm going to do just a little talking on NC Plot, and then we'll wrap up the broadcast. Cool. Gentlemen, thanks for coming, man.
Yeah,
It's great to have you guys.
absolutely.
Jake, it's a pleasure, man. Thanks for stopping by.
See you again.
Appreciate it. And let's see. Give me a sec here, guys, on the broadcast. I'm gonna let's see if I can turn that off. Perfect, and I will be right back. What you guys got going on the rest of the day?
Tiling.
I wish I was Highland.
That's right, you're not at the stage yet, huh?
Not quite, not quite.
What's the next phase? Waterproofing?
Yep, yeah, sanding down the thin style cement part and the water.
Gotcha.
Cool. Gotta get your mastic down and,
What's that?
gotta get your mastic down.
Yeah. Yep.
Yeah, we went, we did the gradient floor heating and everything in the kitchen. That's pretty sweet.
We thought one of my buddies has that and it's really cool.
How long ago did you do that?
3 weeks. Well, it's 3 weeks.
That's sweet. Yeah, we got it in the bathroom here.
Yeah.
Fortunately, because my wife's disability, we sleep in the downstairs bed.
You still walk up here at night and you gotta go.
Oh man, I'll tell you, sometimes when I work late, because only downside, like our dogs will just go nuts. They'll go ape shit if I'm not like in bed sleeping. So sometimes if it's late at night, I'll just go crash in the guest bed to not wake them
Sure.
up and then wake her up because it's always a pain. But man, Okay. Don't know if anybody's still out there. Oh, but I'm just getting back here. Let me turn that back on. We're still live, so I don't know if anybody hung out after Aaron and Jake departed. If you did, that's awesome. If not, it'll be on the video later after the live broadcast is done. So the other thing I wanted to talk about, because this is about like digital tools, right? And you know, I'm a Mastercam guy. I've used Mastercam for a long time. It's been a big part of you know, my career and journey as an NC programmer. But it's for generating G code, and it does some other stuff, and it does it well. But you know, there have been times where I'm coming in. Let's see, you're going to get some lunch. Cool. Sounds great, Ron. Well, for anybody that's still on, we're talking about the NC plot tool, and we're just going to talk about it real quick. I'm not going to spend a whole lot of time on it. I'm a big fan of utilities that provide value. I don't have anything to do with these guys. I'm not involved with the company or the code. Not a representative, distributor, nothing. I just like the product. So I'm going to do a quick search. So this tool's been around for a while, and it is relatively inexpensive. Oh, it's got to have the prices on here somewhere. I know it does. When you download it, it has a whole thing. You get to try it free for 15 days, and then after that, you need to get a license. It's like $300, guys. It's really not expensive. It is a text editor that is also a backplotter, and it's really pretty full-featured. And by that, I mean it understands variables and macro logic. It can do custom macro B, so you can actually set variable values and assign them to variables in your code, and then reference them later, and it will make the jumps or it'll make the loops. Pretty full featured. It can do conversion of arc types, start to center, absolute, center to start, radius. So you can go from IJK to radius. It's got a whole bunch of stuff that's available to you, but it's just a great tool for viewing and working with G-code programs. So I'm going to go to open file. And let's look at let's grab open this sample file. Oh, let's do this one. So this is you know, a G-code program. It's got this little backplot window, and it will do you know, kind of the standard views and isometric. I don't know that it lets you rotate around, so it's not like full featured in that sense, but it is where you can actually click on the G code itself, and it will highlight the line. It'll give you the modal data about the line, and it also highlights the line in the code. Also, if you make edits to the code, you can see those edits visually, and you're working, you know, you're not working at the CAD CAM level, you're working at the NC level. And it's all well and good to say, okay, in our shop, every new program is going to originate in CAM software, and we're only going to edit it in CAM software, and that's all we're going to use. But the reality is, I've worked in a lot of different places where you're coming in and all you've got is this G code program, and you don't really have access to anything else. So how do you know what's even going to happen? All you've got is this text file. Boom. What's this text file doing? Well, here I can look at it in different views. I can really, interrogate visually the file itself. It's also got some really cool features. So if I go to top view, for example, and I'm now looking visually at this pass, right? These are multiple passes that are coming along some wall or some pocket, right? Some contouring passes, and there's some G code. I actually have the ability offset. Actually, I think I have to select it first. Okay, so if I select that code, you can see basically that I'm grabbing those 4 arc radiuses on either side, and these linear lines which were fully inside the window. And I know there's an option on here. Might be shift. There it is. So the translate settings. All right, and here's my orientation. That's X plus, that's Y plus. So let's go minus 1 inch in Y. Did that one do it? Let's see. Oh, I think I actually have to highlight it. So let's go back to the top. Let's try this one over here. It's been a little while, guys, so bear with me a second. Let's go look in the help and let's see what it says for shift. Okay. That's a specified shift amount. Oh, so it's shift. Okay, I get it. It's shifting the it's actually shifting the work offset. So we didn't want that. Anyway, I have done it before. It's escaping me, but I'm reasonably certain you can grab G code and say I need to translate this in a particular direction and get it to do it. I'll have to study up on my NC plot and do another one of these and talk about it a little bit when I can show a real specific example. But some of the other things that it does, converting G codes. So you can see convert coordinates to absolute. So I can take all the arcs, do absolute instead. We've got radius in this code. So let me do, let's grab that G code. And let's go up to tools. and we're going to say convert arc radius to IJK. And so it went through and it just kind of instantly, right, or almost instantly, very rapidly, I would say, converted a program that was programmed in radius to IJK. Address adjustments, address replace, address swap. So we can actually take the numeric formatting and we can change that formatting amount. Change the way that the numbers are formatted, swap codes. So hey, if I want to swap something with something else, I can do that there. I know there was an actual option to convert G-code types for lathe. So when you have like a FANUC A, B, or C G-code system, you can actually swap G98, G99 for G94, G95, kind of perform some of those conversions. So I just wanted to point out this particular tool because I like it a lot. It's relatively cheap, and if we do, let's go back to our samples, and let's go to named variables. And so you can actually set watch lists for variables. So here they've got a bunch of comments about what they're using, a bunch of comments where you can actually uncomment these to set these values and then run through the code that actually does the calculations. So it'll do kind of, really complex macro B logic and allow you to backplot it, test it, make sure values are changing. It's a pretty cool little program. So again, not sure if I'm just talking into the void. If anybody's out there and you're on the chat, go ahead and say hi. So you can see we're playing the backplotter, and based on the codes that are entered up above to set these variable values, the backplotter is actually able to set variable values, reference those values, and you can step through some pretty cool stuff. Anyways, is a program I like. I think it's great for interacting with and working with G codes, and it's really got some great functionality. And you can try it for 15 days, right? So I think it's either 15 instances, 15 times, or 15 days or something. So check it out. Love your comments. Let me know what you think. Yeah. Anyways, I'm going to go ahead and sign off. It was great, seeing everybody on the broadcast, and appreciate you guys spending some time with me on a Saturday.